Alright, kule lesson lena sizokhuluma nge-mechanics, energy, which is a topic on question 5 for this November 2018 question paper. Question 5 ke bathi a skateboarder starting from the top of a ramp 4.5 meters above the ground skates down the ramp as shown in the diagram below. So nasi skateboarder sethu ke bathini bathi siyo skater down the ramp reach point X and then hopefully sifike kubani ku point Y, right? And then the mass of the skater and his board is 65 gram. Ignore the effects of friction. So there's no friction experienced by skateboarder sethu as he slider down the ramp. Okay, now bese bathi ku 5.1, right? Ku 5.1 bathi define the term gravitational potential energy in words. So iskateboarder sethu la sime khona sithi sine gravitational potential energy relative to the ground as isibona la kulelo kule sketch sethu. The ground, the dotted line, is our reference point. So gravitational potential energy is defined as 5.1 as the amount of energy an object has due to its position in the gravitational field relative to some reference point. The reference point in question, Lana, is this dotted line, which is the ground. And then obviously iskateboarder sethu sisi within a gravitational field. If ever planet Earth, just know that ukuthi ungaphakathi kwe gravitational field. So this is how we define gravitational potential energy. 5.2 calculate the gravitational potential energy of the skater just before he skates down the ramp. 5.2 gravitational potential energy, it's EP equal to mass times g, which is the gravitational acceleration times height. So the formula for calculating a gravitational potential energy is this one. So Tina, so calculate potential energy of the skater before he skates down. So calculate a potential energy at this point, at this position, 4.5 meters above the ground, just before he starts skating as well point X. Now, mass is nayo, gravitational acceleration, it's a constant, it's 9.8, the height is 4.5. Now, see our substitutor, 65 times 9.8 times 4.5, as one. 65 times 9.8 times 4.5 equal to 2866. Lana, this is 2866.5 joules. So since it's calculating energy, the units it's joules. Gravitational potential energy, units wakhona, it's joules. So it's 2800. Okay, yeah. Okay, this is our answer for 5.2. And then 5.3. 5.3, but state the principle of conservation of mechanical energy in words. So potential mechanical energy, we know that it's the sum of potential energy as well as the kinetic energy at a given point, right? But the principle of conservation of mechanical energy can be defined as the total mechanical energy in an isolated system is conserved. So conservation of mechanical energy, like this case with the skateboard, this is an isolated system. Why ngisho? It's because of there's no friction. In an isolated system, you don't have any external forces or opposing forces. So mechanical energy is conserved in a isolated system. That's the principle of a conservation of mechanical energy, right? 5.4, use the principle stated In question 5.4, to calculate the magnitude of the velocity of the skateboarder when he reaches the ground at point X. So into esifunayo ke thina nayi, we want velocity of the skateboarder at point X. Sifuna velocity at this point X. So sebenzisa mechanical energy, the conservation of mechanical energy. So nabathi the total mechanical energy in an isolated system is conserved. Bachaza ukuthi the mechanical energy before is equal to the mechanical energy after, or singayistate as singathi mechanical energy at the top, which is before, and then the mechanical energy at the bottom, which is after, azoba equal according to the principle of conservation of mechanical energy. Then sizothini ke siyazi ukuthi at the top the skateboarder izobe stationary, so akana kinetic energy ke la, right? Angeke abe ne kinetic energy at this point la ame khona manje, at this point where ame khona, at this point right here, kule point lena, we know that angeke abe ne kinetic energy since u stationary, right? So and then we did calculate potential energy ku 5.2 at the top. So I do have a value for this one. Lana it's going to be 0 since it's stationary at the top, and then the kinetic energy at the bottom at point X is about 0, right? 0 since there's no height at point X, there's no potential energy at point X since ukulokanje nakasuka la uzoba lana, and uzobe on top of the reference point, or uzoba in line with the reference point. So to calculate the velocity sizosebenzisa the kinetic energy at the bottom, right? I substitute la. Potential energy is calculated as mgh, lana it's plus 0 as I've explained. The kinetic energy is 0 at the top, equal to 0 plus half mass times v squared. This is the formula for a kinetic energy. Now at the top calculated with the potential energy, it's 2866.5 plus 0 is equal to 0 plus 1 over 2. Mass is 65. Velocity is unknown. The velocity at X, at point X, is unknown, so lana si share as v squared. Then it's your calculator for uv, or we're going to make uv the subject of the formula. So this plus 0, it's 2866.5 equal to half times 65, half times 65 is equal to 32.5, so it's 32.5 v squared. Therefore v is over equal to 2866.5 divided by 32.5 square root. So the square root is remove the squared v squared. So our v is equal to square root 2866.5 divided by 32.5. Answer masithathe into 2 decimal places, so it's about 9.39 meters per second. So this is the velocity of the skater at point X. This is our answer for 5.4. 5.5. Will the skateboarder be able to reach point Y if he were to remain on his skateboard yes or no, and support the answer with a relevant calculation. So for this one, 5.1, sizoqala nge-calculation, then we'll provide an answer afterwards. So bachaza ukuthi if ever nakafika la ku point X, he decides to stay on the skateboard. Angisho obviously uzosuka la eze la ku point X, nakafika ku point X, if ever u decide ukuhlala kule skateboard or akayi kule skateboard, then uzoya phezulu or uzogibela le ramp le aye kulo guy aye ku point Y. So we want to know ukuthi uzofika ku point Y, yes or no. So asicale ngelo guy nge-calculation ke la. So let me provide some space. So lana ku 5.5 we want to calculate the height azofika kiyo, right? So usuka la ku X uya kubani uya ku Y. We want to know ukuthi uzofika ku Y, yes or no. So nangabe ufika ku Y, it means i-height yakhe kuzoba ubani uzoba 6 meters. So in this case usebenzisa the principle of conservation of mechanical energy again, but this time is calculator the height of the skateboarder for angisusuka from the bottom to the top. So sizo calculator i-height when he reaches the top. If the height esiyicalculatayo ilingana no 6 meters, it means uzofika ku point Y. If it's less than, it means anyeke afike kubani ku Y. So na into izowenzeka ke sizothi EP plus EK for the top, which is some point lana or some point la ku Y. We don't know. We just want to calculate to find the height kala, then we can conclude. So usuka from X uya kubani uya to the top. This is the bottom and then this is the top. Sifuna calculate the height azoyireacha nakafika kulo guy at the top or the peak of ilo guy of the ramp. Now siyothi ke at the top part we know that about mgh, the potential energy plus the kinetic energy, right? The kinetic energy at the top kuyoba ubani uzoba u0. Why do I say that? Ngoba the skateboarder nasuka la it was 0, nakafika la at the bottom the kinetic energy it's no longer 0 since seka gain some speed nya, so seka gain some velocity nya. So nakasuka la ku X uzo ya up ramp, nakafika at the top obviously komele ayenzeni a stop, right? So therefore that's why ngithi kinetic energy at the top izoba ubani izoba u0 ngoba nakaya phezulu uzo slower down naqeda ayenzeni a stop la. He might go back or angavele I stop le skateboard from sliding backward. So lana it's equal to the potential energy at the bottom, it's 0, plus the kinetic energy at the bottom. The kinetic energy at the bottom you about half m v squared, half m v squared, since at the bottom is nailo kanje a velocity, so it does have the skateboarder does have a kinetic energy at point X. So the mass is 65, 9.8, height unknown. We want to calculate the height. Sifuna ukuthi uyofika la ku Y. If the h is calculated as 6, we know ukuthi sekafikile ke ku height. So this value plus 0, it's this value, 0 plus that, you about half 65 v squared. Hey, wait, I do have a velocity. The velocity is calculated as 9.39, so lana is squared. Therefore our height is over equal to half, you divide both sides by this 65 times 9.8, so you about half 65, 9.39 squared divided by 65 times 9.8. So our height is equal to half times 65, 9.39 squared divided by 65, 65 times 9.8 equal to 4.50 in 2 decimal places. Shift fixed to 2 decimal places is 4.50 meters. So therefore i-height yethu mhlawumbe niyophelela somewhere la, 4.5 meters, uyabona, which is just below ubani 6 meters. So our skateboarder izophelela lana, it will never reach ubani point Y, since point Y has a height of 6 meters, and then yena only reach 4.5 meters. So this concludes our question 5. This is the last question. Thanks for watching. In the description below ungakhohlwa uzothola ama links for other questions ongaphendulile for this question paper. If ever you're interested, please check them out. Now we're new to this channel, just consider subscribing. Ungakhohlwa ukulike, ungakhohlwa ukushare nabangani bakho if ever uthole some value out of this video. So yeah, asibonane on the next video. Bye bye.